Organic Friday, we are talking about substitution reactions. Now, substitution reactions sound just like the name, right? One atom takes the place of another atom, all right? The atom that's getting replaced was attached to a carbon. So we've got the general pattern here, right? RH, right? Maybe an alkane, reacting with a halogen, right, to make an alkyl halide. And HX. Right. Now, I was reading up on the halogens in these reactions, and it turns out iodine isn't very reactive, so it doesn't usually do this. Right? Iodine's not reactive enough to undergo these reactions typically. And fluorine tends to cause all kinds of nasty things to happen to your organic compounds. So you can't really do this reaction with fluorine either. So you're basically limited to chlorine and bromine being able to do this substitution. So what the halogen does is it kicks a hydrogen out of the alkane, takes its place. I should point out there's really not much change in the bonding. So if this is an alkane and everything's single bonded, it will still all be single bonded at the end, right? There's not a change in bonding with the substitution reactions. We did see changes in bonding, remember when we did addition reactions, we went from double bonds to single bonds. But here, the bonding stays the same. So that's really what we're doing with substitution reactions. So I think we'll do a couple as a class, and then we'll turn one into the reaction of the day. So the first reaction, chlorine reacts with methane. So we have chlorine gas reacting with methane. What's the chemical formula of methane?
CH4.
CH4. Right. So what could be a product here?
HCl plus CH3.
HCl plus CH3.
Right.
Cl. All right. So we'll make an alkyl. We'll make chloromethane. Now, if you have enough chlorine, you could actually get more than one hydrogen to be substituted. So you could go on and make CH2Cl2 or CHCl3. You could go on and have more substitution. Sound good? And benzene derivatives, things that are aromatic, can also do these kinds of substitution reactions. We're not worrying about the mechanism, just the basic reaction. So cyclobutane is treated with bromine in the presence of ultraviolet light. Well, what does cycle mean? They're in a ring. How many carbons? 4. So how many hydrogens are in this molecule? 8. And we're going to react it with bromine in the presence of ultraviolet light. How could I show that? UV. All right, I could write H nu over the arrow.
Yeah.
All right, or you could write light over the arrow if you wanted to indicate that. What will my products be? HBr.
C4H7Br.
C4H7Br. That's right. So one of the hydrogens perhaps got substituted. Right. Of course, other more substituted versions might show up. So it's not implausible to think that you might have some molecules with 2 bromines or 3 bromines. But we just want to make sure we've got the basic pattern. Are we good?